For me, the function f of x equals x is called the parent function. In other words, it's the most basic linear function there is. Does anybody remember what's another way we can name a function when it's given as f of x equals x? What's another way I could say that? Isaac?
Y equals x.
Yeah, or y equals x. That's the most basic linear function there is. F of x means the same thing as y. Well, what happens is we take that parent function, that basic linear function, and we transform it. Whenever it isn't just y equals x, that means a transformation has happened to it. It has changed somehow. Okay, so here are the two changes the only two changes we have to worry about learning this year, okay? We have to worry about, this is our first one, changing the y-intercept. So could we take over here, and I think you have a little bit of white space over here. Up here, can we put, for the parent function, could we identify what the y-intercept actually is? What is the y-intercept of the parent function? Everybody think about that for a bit. What's the y-intercept of the parent linear function? What's the y-intercept of the parent linear function? In other words, if I said to you, you need to write b equals something, what would you write? Okay, what would we write? Hands up if you think you know. Just you're willing to take a chance and say, I think I know what the y-intercept of the parent function would be. Really, only this many of us? Okay. Now keep your hand up if you're willing to be called up. Okay, what do you think, Malcolm? What do you think the y-intercept is? 0. Yeah, the y-intercept is 0 for the parent function. So if the y-intercept is going to change, that's a transformation. If the y-intercept changes, that causes a transformation. And the transformation that it causes, so when you change the y-intercept, that's called a translation. Would you underline that? Changing the y-intercept, that is called changing, that's called a translation. A translation will occur. That is the type of transformation that happens. And a translation, by changing the y-intercept, what happens is you're either going to move it up or you're going to move it down. The line's going to move up or the line's going to move down if the y-intercept changes. Okay?
So it can't go side to side.
Can it go side to side? It can. That's another type of translation that we're not going to study this year, called a horizontal translation. We're only going to study the vertical translations. They're the easier ones, by the way. We get to just study those right now. Okay, so we have, here, there's 3 lines on this graph. Notice it says right here, it says this one in the middle that's going through 0 on the y-axis. That one is the parent function. That's our y equals x1. Okay, that's the one I just made blue right now is our parent function, our y equals x1. Well then, so that's our f of x equals x, that's that one, the parent function. What's different about this g of x equals x plus 2? What changed?
The f.
Well, the f of x changed g of x, and that's because it's a new function. So they, instead of using f, they just used a new letter. Trey, what changed in that?
You transform changing the position of the lines.
Okay, how did it change in the equation?
It goes
And it went up plus 2. So in other words, it has this plus 2 now, and so its y-intercept would be 2 instead of 0, like the parent functions. What changes in h of x equals, notice just a new letter because they're saying got a third function here. What changes there? The y-intercept changes to what?
Negative 4.
-4. So here's our one where it's crossing at -4. There's our h of x equals x minus 4. Here is our one where it moved up 2. And we have our g of x equals x plus 2. So notice the line still has the same what? What didn't change? Brighton?
The slope changed.
Yeah, the slope didn't change. Are all those lines parallel?
Yes.
Yeah. So the slope didn't change. They all have the same slope, but they all have different y-intercepts. So we call that the transformation that happens to make lines be parallel is you change the y-intercept. It's called a translation. Okay, so when the y-intercept changes, here's what we're gonna do, we're gonna say, oh, a translation happened. And then we're gonna talk about, we're gonna be able to describe it. Okay, and then the other thing we're gonna be looking at is changing the slope of a line. What if the slope changes?
It's not gonna be parallel.
So changing the slope of a line changes its, what happens when you change its slope? It's kind of like its direction, yeah, it's, what it will do is we're gonna only have to worry about it changing its steepness. It's either gonna get steeper or it's gonna get less steep, okay? And so what is the slope of the parent function? What's its slope? What's the slope of the parent function? Ariel? Seth? Riley? Oh, Cameron, you have your hand up. Okay, thanks, Cameron. It's 1. Okay, so I'm calling on some names because I'm seeing like unengaged people. M equals 1. M equals 1 for the parent function. So when we have the parent function, here's our parent function again, the one that I'm gonna do in blue. When they're all on the same graph, it gets kind of confusing. There's the parent function going through 0. It has a slope of 1. Well, notice what happened when we changed it to h of x equals 1/2 x. The y-intercept didn't change. The slope changed to 1/2, and what happened? Did it get steeper or less steep than the parent function?
Less steep.
It's less steep. It flattened out. And what happens when it becomes that was h of x, sorry. When it becomes g of x equals 4x, that's this one right here. How's that one compared to the blue line? Steeper or less steep?
Steeper.
Steeper. So tell me something about how are we going to be able to tell when it's going to get steeper when we don't have a graph? Just looking at the equation. How do we think we're going to be able to tell when the new line would be steeper than the parent function? Cameron?
When the slope of the next, or the new line is greater than.
Yeah, when the slope of the new line is greater than 1. The one that is steeper on here has a slope of 4, and that's greater than 1. And when it's less than 1, what happened? It got less steep, didn't it? Yeah, so those are going to be things that we're going to use to help us make decisions about it, okay? So they want us to graph f of x equals x and g of x equals x plus 3, and then describe the transformation that happened, okay? And on the back, we're going to do it without graphing, I think, but I'm not sure at the moment. So let's put f of x equals x and g of x equals x plus 3. So we already said, and this is always going to be the case for the parent function. The parent function is always going to have a slope and a y-intercept. What's the slope can always be for the parent function? 1. And the slope is, the y-intercept is 0. Okay, let's go graph the parent function first before we even, so go ahead and graph that. So put your starting point, use the slope of 1, get the parent function graphed. Make lots of points for the parent function because the parent function's points are pretty close together. I like to make lots of points for the parent function. You should get so used to graphing the parent function you can almost do it without thinking. Start at the origin, go up 1, over 1, down 1, over to the left 1. Just keep climbing the steps one at a time. Okay. Then let's go on to identify what is the slope and the y-intercept of g of x. What's the slope of g of x?
1.
1. M equals 1. So it didn't change. The slope didn't change, did it?
No.
No. Okay. What's the y-intercept?
3.
3. So the y-intercept did or did not change?
Change.
Did change, didn't it? So what should our expectation be before we graph this, right?
It should be
They should be parallel because why?
The slope never changed.
The slope didn't change, so they better turn out to be parallel lines, huh? Okay, so let's start at 3 on the y-axis, and let's make points for that one. So this one is our, here this one is our f of x, and this one right here is our, oops, and this one is our g of x. Always kind of good to be, you don't have to write out the whole equation, it's always good to give them kind of like the label on the graph to be like, oh, which line is which? Well, the bottom one is actually our parent function f of x. The top one is actually our transformed function g of x. Right?
If our parent function belongs to the same sheet, so they're not here.
Yes. Kind of just a good idea to have them both labeled so you can just look at it. Okay, and now it says, then describe the transformation from the graph of f of x. In other words, how did it change from being f of x to the graph of g of x? How did it change? What transformation happened? Dakota? Yeah, but we're going to use we're going to actually use the technical term which is called translated. Okay, it translated up how many units?
3.
3 units. Okay, so let's put g of x is translated. Oh, see, that's not right. I don't want to say it that way. Sorry. I'm going to say f of x is. F of x is translated up 3 units. That is the transformation that happened. F of x is translated 3 units up. That's how we got to g of x. And we can see on the graph, you should be able to, between every point on f of x, you should be able to count up 1, 2, 3, and you should be on the next line, no matter where you start. If I start here, I should be able to count up 3, and I should land on a point on the other line. Go up 3 between every point. You should be able to go up 3, and land on the new line. Okay? Okay, so let's look at number 2. Now we have f of x equals x. What's that called again? What's that one? What's the name of that one? Parent function. And then we have g of x equals 3x. Well, we know that every single time for the parent function, it's going to be m equals 1, b equals 0. So, again, like I said, you're going to get to the point you're going to be able to almost graph the parent function without hardly having to think, but graph the parent function first. And then we'll go on to g of x. This is our f of x, this one. Okay. G of x. What's its slope?
1, 3.
3. What's its y-intercept?
0.
0. Okay, so its y-intercepts, it starts at the same place, but it has a different slope. So we start at 0, 0, and we go up 3 and what? Right 1. Or we can go down 3 and left 1. Okay, and we draw our line through that one's points.
So they're not quite parallel.
Are they parallel this time? Are they perpendicular?
No.
No. Why aren't they perpendicular? Oh, why aren't they perpendicular?
Because they don't make a.
Pros? Not because they don't cross at right angles. Tell me why, because of something to do with their slope. Tell me why they don't end up. Their slopes, well, their slopes aren't supposed to be the same, they're perpendicular. Brighton?
Because their slopes aren't the opposite of each other.
They aren't the opposite of each other and they aren't reciprocals of each other. 1 and 3 are not opposites and reciprocals, are they? No. So it shouldn't have turned out perpendicular, but we don't, that doesn't matter, we're not working with perpendicular lines, we're saying, what does changing the slope do in this situation? What does it do? What transformation happened? It got steeper, it's a rotation, yeah, so we're gonna say that f of x is rotated, we forgot to talk about what kind of a transformation that was up above, is rotated and got steeper. F of x got rotated and got steeper. So it's a lot more work to climb if you happen to be climbing those lines. Okay, so when the slope changes, that's a rotation. When the y-intercept changes, that's a translation, isn't it? Okay, I guess we are graphing on the back, so we've got to get moving to the back. Unless you have questions on any of this part on the front yet. Okay, let's go to the back. Okay, it says describe the transformations from the graph of f of x to g of x, then graph them to verify. So in other words, it wants you to do it from the equations. So let's just do what before, without graphing, let's just do our getting ready to graph and use that to help us say, this is what I believe should happen. So at number 3. Parent function, what's its slope and y-intercept? 1 and 0. How about for our new function, g of x? What's its slope? 1. What's its y-intercept?
4.
4. Oh, so tell me, what changed? The y-intercept changed. If the y-intercept changes, what's that mean happens? They're going to be parallel, but if the y-intercept changes, what transformation is that again? The translation. So we're gonna predict that it would translate f of x would translate, but when we talk about it translating, we have to say how much and what direction. What do you think, Josh? 4 units up. Yeah, should go 4 units up. Why would it go 4 units up, Josh? Why did you make that decision? Any idea?
The y-intercept is 4.
Yeah, the y-intercept went from 0 to 4, so it's at 0 and it's going up to 4, so we're thinking it should change to, it should translate 4 units up. Okay, let's graph them and see if that's what it looks like happens. Okay, so let's get our parent function on there first. Love doing the parent function.
This is a branch Marky is written to me, so
Okay, and then go ahead after you get f of x graphed and line drawn everything. Then I want you to do the g of x next, get that one graphed. And remember, we're graphing to verify our conclusion that we said f of x would translate 4 units up. So after we have graphed it, do we feel good about the type of transformation we described?
Yes.
Yes? You are done? You're feeling like we described it well? Did the steepness of the lines change at all? Do they have the same steepness? They have the same steepness, don't they? Yeah. In other words, they're parallel to each other. So what changed in the equation? What changed in the equation for this transformation to happen? The y-intercept. Okay, so for a translation to happen, it has to be the y-intercept that changes. Okay. Any questions on that one? Okay, then let's go on to number 4 here, where we are going to, again, we have the parent function, which has become almost a no-brainer. And we have the transformed function. And we say, that one we have to do some thinking about. What's the slope of that one?
1/3.
1/3, okay. And the y-intercept? 0. What changed this time?
Sorry. The slope.
The slope changed. Did the y-intercept change?
No.
No. Okay. So remember, we're gonna use the graph to verify it right now. What we're gonna do is we're gonna describe the transformation without graphing it first. So what are we gonna say that we think f of x will do? F of x will what? Cameron?
Rotate.
Rotate. And we have to not only say it'll rotate, but we gotta tell something about like how will it rotate? What will happen to its steepness?
It will be less steep.
Okay, and be less steep. Why are you deciding it would be less steep, Cameron?
Because 1/3 is less than 1.
Because 1/3 is less than 1, so Cameron's predicting that the line should be less steep when we graph it. It should be flatter, in other words, than the parent function. So go ahead and graph both of those. You're getting really good at this. What does a rotation mean to you? You could say something rotated, what did it do?
It changed the direction.
Yeah, it changed direction, it turned, didn't it? Okay, so it rotated and turned. So does it look like the parent function actually turned?
Yes.
And did it get less steep?
Yep.
Okay, so we have a rotation, we have to talk about its steepness. What makes it rotate, what makes it turn in the equation? Changing the what?
The slope.
Changing the slope makes it change. Okay, so those are the things we're gonna look for. Okay. We have just a couple more to do. Hang in there, you can do it. So, anybody have anything that we need to clear for them though at the moment before we do move on? Okay, then let's move on. Parent function, m equals 1, b equals 0. Transform function, m equals
1,
1, b equals
-1.
-1. So, graph your parent function, draw its line. Graph its points, draw its line. But then stop and say, okay, here's what I think is going to happen to f of x before you graph g of x. And write down, what do you think is going to happen to f of x, considering how we've described it to above? Or do you know what changed? Anybody want to offer up what they think is going to happen? Stefan?
It will go down to 1.
Oh, f of x would, and what's that called? Translate, would translate down, how much? 1 unit, yeah, down 1 unit. Because the y-intercept changed from being 0 to -1, so what should happen is the whole line should move down 1 unit, right? Is anything else going to happen? Any other changes going to happen? The slope change? When the y-intercept change, that's what's going to make the translation happen. Does the slope change?
No.
No, so we probably won't rotate, so let's check it out and see what happens. And sure enough, they didn't, the steepness did not change. They are both climbing at the same rate. The only thing that changed is every point on that line drops down one. It's a translation down 1 unit. Okay, I want you totally to do number 6 on your own. Totally do number 6 on your own. If you have questions about number 5 before you move on to 6, get your hand up so I can come and help you out.
You want to see number 6?
Yep, I want to see your number 6 when it's done, okay?